In this course, we'll be studying trigonometry. Trigonometry was originally referred to the measurements of triangles. Much later on, it went on to include the use with functions, measuring rotations and vibration, in particular sound waves, light waves, planetary orbit, vibration of strings, pendulums, and many other functions. The basic foundation of trigonometry is our angle. An angle is formed by taking a ray and rotating it about its endpoint, the vertex. So if we take this ray, which we call the initial side, and rotate it around, where it ends is known as our terminal side, and in between our initial sides and our terminal sides we have an angle. An angle can also be represented in our rectangular coordinate system. Here we have our x-axis and our y-axis, where the initial side is on our positive x-axis and the vertex is at the origin. If we rotate our ray around, we produce this angle here, and angles we could call this alpha, and this angle here beta. Angles in a counterclockwise direction are positive, and angles in clockwise directions are negative. So here alpha would be a positive angle and beta would be a negative angle. Now if you notice, both alpha and beta have the same initial and terminal sides. Angles that have the same initial and terminal sides are known as coterminal angles. So angles alpha and beta are coterminal. There are actually two different ways of measuring our angle between our initial and terminal sides. One method is by using a radian. A radian is defined as a measure of the central angle. So here's our central angle, and we call it theta, that intercepts an arc S. So here we have an arc. It intersects our arc S, equal in length to the radius of the circle. So here we're saying this is our radius and this is our arc. So 1 radian is when S is equal to R. So here we have theta is equal to S over R, where theta here is measured in radians. We just mentioned that theta, the angle in radians, is measured by the arc length of a circle divided by the radius. So if we know the arc length and we divide it by the radius, then that will give us our degrees in radians. We know for one complete revolution that the circumference of a circle is equal to 2 pi r. So in one revolution, theta will be equal to 2 pi r over r. Therefore, our degree, our angle measurement in radians would be 2 pi radians. So for one complete revolution from the initial side back to the initial side, it's 2 pi radians. For 1/4 of a revolution, that would be 1/4 times 2 pi radians, which simplifies to give us pi over 2. So 1/4 of a revolution would be pi over 2. For half of a revolution, we have half times 2 pi, which is equal to pi rad. So this will be equal to pi radians. And for 3/4 of a revolution, we have 3 over 2 pi. 3 pi over 2. So angles between 0 and pi over 2 is in our quadrant 1, and here from pi over 2 to pi is quadrant 2, and from pi to 3 pi over 2 is quadrant 3, and from 3 pi over 2 back to 0 would be in quadrant 4. Angle is also in our first quadrant. So here if we have an angle theta, this is known as an acute angle. An angle measured in our, let's call this one beta, in our second quadrant would be known as an obtuse angle. So acute angles are less than 90 and obtuse angles are between pi over 2 and pi rads. Now let's get coterminal angles again. An angle theta has infinite coterminal angles, and that infinite coterminal angles are given by theta plus 2n pi, where n is an integer. So here we're saying if this is our theta, which is equal to pi over 4, we can find another coterminal angle which has the same initial and terminal side by making one revolution. So one revolution plus pi over 4 will give us a coterminal angle. Similarly, two revolutions plus pi over 4 will give us a second coterminal angle, or three revolutions plus pi over 4 will give us a third coterminal angle. And this continues on infinitely. We could also go the opposite direction, from here to here, to get a negative coterminal angle. So here we're saying theta, to find our coterminal, theta is equal to 2n pi, where n is an integer, meaning a positive or negative. That means we're adding or subtracting 2 pi. So for pi over 4, we can find a positive coterminal when n is equal to 1. This becomes 2 pi, so it's pi over 4 plus 2 pi, which gives us 9 pi over 4. So this angle here would be 9 pi over 4. To get a negative coterminal, so n is equal to negative 1. So it becomes pi over 4 minus 2 pi. Now we're going the opposite direction, which gives us negative 7 pi over 4. So this angle from here back to here in the opposite direction would be negative 7 pi over 4. So here we have two coterminal angles for pi over 4, negative 7 pi over 4, and a positive 9 pi over 4. Now let's get two additional definitions that is commonly used in trigonometry. The first one has to do with complementary angles. And complementary angles are two positive angles whose sum is equal to pi over 2. So here we have two angles. One is alpha and beta, and here we have 0, and this is pi over 2, the first quadrant of our circle. So we know that these are complementary, so alpha plus beta is equal to pi over 2. Our second definition is that of a supplementary angles. Supplementary angles are two positive angles whose sum is pi. So here we're going from 0 to pi, which is a half of our circle, and these two angles here add up to pi. So alpha plus beta is equal to pi. Now here in this example, we're asked to find the complement and supplement of pi over 3. We know that complements add up to pi over 2. Therefore, to find the complement of pi over 3, it would be pi over 2 minus pi over 3. So pi over 2 minus pi over 3 gives us pi over 6. To find the supplement of pi over 3, it would be pi minus pi over 3, which gives us 2 pi over 3. Now please know, not every angle has both a complement and a supplement. Only angles in the first quadrant will have complements. An angle in the second quadrant over here will not have a complement, because complements have two positive angles whose sum is pi over 2, and you can't have two positive angles whose sum ends up in the second quadrant.